The physics of curling. The reason I chose curling is because I saw it live as a kid and I was really interested in it. Physics plays a big role in it, as you can tell, which made it an easy topic to choose from. And it's a team sport, but everyone still has their own job to do, which I thought was really cool. Something about curling was it was invented by Flemish immigrants around the 16th to 17th century, and it was first played on frozen ponds in Scotland. The goal is to get your stones as close to the center circle as possible while keeping the opponent's stones away from that. And it's played in arenas on ice on about 42.5 meters by 4.75 meters. Speed is the rate at which something is able to move or operate, and it's also set up by the equation distance divided by time. And velocity is the speed plus direction. Acceleration is a change in velocity, which is either speed or direction. And then force equals mass, which in this case the stone is 17 to 20 kilograms. And then you take that mass and multiply it by the acceleration to get the force. Force is also a push or pull that act on an object. In curling, you want friction to be eliminated as much as possible, which is why the stones have become polished so that there's as little friction as there can be. And then the sweeping of the broom heats up the ice so it melts, which reduces the friction between the ice and the stone. And then the less friction there is, the farther it can go. And friction is a force that opposes the motion of objects that touch as they move past each other. Gravity is the attraction between any two objects because of their masses. And so gravity in curling causes the stone to curve. The force of friction in the front and the force of friction in the back cause the stone to spin. The friction in the back must be more than the friction in the front to cause it to spin. And in this case, when the handle is tilted clockwise a little bit, it'll cause the whole stone to start rotating, which causes the curl or the curve. Newton's first law is that an object at rest stays at rest and an object in motion stays in motion. This means that the stone would keep going on unless it was acted on by an outside force, which is the friction, which slows it down. When the stone stops, it will also stay still until another stone comes and hits it and moves it. Newton's second law, the acceleration of an object is directly proportional to the magnitude of the force, means that the more force that you will push onto the stone, the more acceleration it will have while it's rolling down the ice. Newton's third law of motion, for every action there is an equal and opposite reaction, means that the stone pushes another stone when they collide, and then its force transfers through and causes that reaction to have the other reaction. Velocity and acceleration. You can find the average speed or velocity that a stone had while getting slid to the tee by taking its distance from where it was thrown to where it stopped and divide it by how long it took to get there. The athlete throwing the stone decides the stone's speed and velocity by how much force they use to push it. A harder push would use more force and increases the speed. For curling, you need the right amount of velocity to make it to the center circle without going too far and then going too short if your sweepers can't sweep it to the circle. You would generally like more acceleration in the beginning so you can get enough speed to carry it all the way there, but towards the end you definitely want the acceleration to decline. The stone has many forces itself, as you can see in the picture. It has gravity weighing it down, it has the ice weight pushing it up, it has the force of acceleration moving it forward, and the force of friction moving it backward. This is why precise force is needed by the thrower to make sure that it can handle the friction and outweigh it until it gets to the very end in the circle. Also, when a stone collides with another stone, it transfers its force to the other stone, which causes that stone to move.